Okay, let's talk about an overview about solving a fluid problem with viscosity. So of course we're gonna use a Navier Stokes equations. Here it is. You can check on the Wikipedia. Um, uh, and most commonly we will have incompressibility. So we will result into those two equations, and then we'll apply boundary conditions. And of course, we can change the system of equations with certain symmetries, and also we can use some extreme conditions such as low Reynolds numbers and such for laminar flows. For boundary conditions, there's few common ones. For the around the rigid body on the surface, the fluid should stay on the surface in the sense that the velocity of the fluid is the velocity of the surface of the rigid body, and the fluid won't penetrate into the rigid body. That means there's no velocity that is perpendicular to the surface of the object, and thus we have non-slip, and then non-penetration. At infinity, if we have a constant flow, then we have this boundary condition. So in general, the workflow will be examine the symmetry if we have like spherical things or some cylindrical things. We will reduce the degrees of freedom using the symmetry, and we will examine the assumptions. For instance, if we're having a really low flow, or we have ideal fluid, have zero viscosity. If we have incompressibility, then we can reduce the equation we're going to deal with. Thus, simplify the question. So we have the first two are basically simplify the system of equations, and then we use the system of equations and boundary conditions, and also keep in mind there's a lot of very useful vector identities to use once you are trying to solve for the solving for the system equation. It will massively reduce your work, and of course, ultimately you can put into solvers, Mathematica, and such to solve the system equations.